invite on stage our next moderator, Mr. Chanchal Das Gupta. Let's give it up for him, please. I'd also like to invite on stage Mr. R.O. Swaroop, Dr. Ajit Salvi, and Mr. Agam Mathur. Please put your hands together for these lovely gentlemen. Before I hand over the mic to our moderator, Chanchal Das Gupta, a little bit about him. Chanchal is an application marketing manager, infrastructure for Borouge Asia South, and is in charge of marketing of Borouge PE and PP infrastructure products in the Indian subcontinent. A chemical engineer from Jadavpur University, Kolkata, Chanchal started his career at Indian Petrochemicals Corporation Limited in 1986 in technical service and application development for polyolefins. Since 2001, he is working for Borouge for market development of Borstar PE and PP grades for infrastructure applications. He has presented papers in many international conferences. He's also the winner of Borouge Innovation Award on 4 occasions and has 3 application patents. Thank you. Mr. Chanchal Das Gupta, please take over the mic.
Thank you, Shruti, for the introduction. What a conference this has been. I think every session has raised the bar compared to the previous one in terms of diversity and new information. This session is also going to be very exciting. We have a combination of experience and enthusiasm. We have 2 very experienced water professionals who have worked for more than 30-40 years, and we have a new gen entrepreneur and technocrat. So first paper is from Mr. R.O. Swaroop, Head of International Affairs. I'll just introduce him. His topic is Design Nonsense for Plastic Pipes in HDD Process, a deep dive into pullback forces. He is the Head of International Affairs at the International Society for Trenchless Technology, INDSTT, carrying the rich legacy from his father, Dr. Niranjan Swaroop, where he oversees the organization's global initiatives fostering international collaborations and technological advances in trenchless technology, affiliated with notable bodies such as CIDC, NASTT, and Tau Beta Pi. RO's contribution reflected deep commitment to the engineering community both in India and internationally. With a focus on sustainable and innovative infrastructure development, RO's leadership at INDSTT and active engagement in the field have made him a respected figure in the trenchless technology sector. His expertise, particularly in the integration of plastic pipes within the HDD process, makes him a sought-after speaker at industry conferences worldwide, where he shares insights on minimizing environmental impact while enhancing efficiency. So with this introduction, it's over to Mr. R.O. Swaroop.
That's a very humbling introduction, Mr. Das Gupta. Thank you very much. And good afternoon to everyone. I hope everyone had a great lunch. I know my topic involves a lot about technology and technical aspects, and my theme is going to be more about technical formulas, when we are talking about design. So I'll try to keep it less boring and more on the point for our audience here. So the title in simple terms is Pullback Forces for Designing HDD Operations. A little bit about myself. I did my bachelor's in civil engineering from D. Muthal, master's in civil engineering, focusing in trenchless technologies at University of Texas at Arlington. Currently pursuing my PhD as well. Well, learning never stops, so that's there. And while side by side, I'm serving as the head of international affairs at Indian Society for Trenchless Technology. For today's session, I'm going to go over a quick introduction of the HDD process. Although one of the former presenters have discussed the nuances on planning an HDD process, I'll quickly introduce the process through images and videos as well. Moving on, we'll discuss why we want to understand the pullback forces and how does plastic pipes come into decision making when we are talking about pullback forces, and what can go wrong if we don't estimate them in the right way. There are two different ways to calculate them, ASTM and PRCI methods. I shall be going over them quickly. That's where the math is, that's where the formulas are. And then I'll go over a bit more resources and go over a bit about IND-STT. So a quick introduction to HDD process and the pullback forces. Basically, an HDD process is an operation which has three core processes within it. The first process is basically your drill head drilling a pilot hole in the ground in the shape or design of the borehole, which is already prepared by your design team or the client, or the client team or the client's consultant team. Then the process of reaming comes once your pilot borehole is complete. The hole is expanded, typically 1.5 times the diameter of your hose pipe, which is to be installed. So reaming process, it's not just a single type pass. You need to pass the reamer multiple times through the borehole in order to attain the diameter of your borehole that you want to stabilize. And then there's pullback process, which is where your role comes in, your machine, your product comes in. Your product, as in your product pipe, it's pulled back through the borehole, which is expanded, and via the reaming process. So it's pulled from either entry side or the exit side, and it bears some form of loading that we'll see. So when we are talking about pullback force, it's basically the force which is required to pull the pipe, plastic pipe or whatever material pipe it is, pull it through the borehole from the entry of the pipe to the exit of the borehole. It must overcome two things: the friction, which is caused by the ground, as well as the drag forces that will be caused due to the drilling fluid. See, we are drilling in the ground and we'll require a lot of fluids passing through. Bentonite is there. There are other mixed compositions that goes in there. So there's bound to be drag force that is involved. In this session, we'll see the differences why drag force cause a difference in mechanism or design as well. This is a quick video. I think it plays, right? Yeah. So this is a quick visualization of the site conditions during the pullback stage. What your products actually go through is what this process looks like. So this is the one end where the HDD machine, your drill rig is present, and it's going to pull back the pipe through that entire borehole. In this case, it's a steel pipe. The same process is no, it's not steel. Yeah, in this case, basically, this whole process is generic for all types of pipe materials. And for the gentleman in the second row, you may observe that there's a reamer also attached in before to make sure you have a clear pass. Why is it important to have a clear pass? I'll show you in the form of images. Basically, each drill pipe is taken out. In that process, it's untied, it's taken out, then your rig gets attached to the next one, and then it's pulled back again, and that series of process goes on and on. And you see, this is called the luckiest day of your contractor. So now that we have gone through this process, now that we have seen how it looks above the ground, why is it essential to know these forces? That is the challenge, right? So when we are talking about determining these pullback forces, it comes down to what our conditions are to set the project parameters. First thing, we need to know what is the strength of our machine. And that's where the strength dictates the selection of your drilling rig. The second point is where you guys come into play, which is pipe material and type selection. So when we are talking about that, your pipes bear ability to bear tension as well as surface damage, that dictates which pipe to be selected for this particular project. When we are talking about these aspects, typically the failure we talk about is more in kinking or tensile failure of the pipes. And then that's where we determine where, like, we determine the parts where we are bound to experience the most forces. That's where the understanding the exponential effects of the small parameters that are present in the ground. Small parameters, we talk about lubricating the ground using drilling fluids, right? But those drilling fluids still, they minimize the friction, they don't make a frictionless surface. God helps us. God would help us if we could make frictionless surface. Everything would be ideal for 11th grade physics student. What can go wrong? So this is a situation where there are two different situations. There are two different ways things can go wrong. When we are talking about overestimation of load, we talk about higher pipe wall thickness leading to a decrease in flow and added cost, or a bigger drill rig selection than it is required. More pullback, basically a higher pullback force, a higher pullback rig is selected for project condition as easy as sand. When we are talking about underestimation of loads, that's where mess happens. Messes as such, your pipe may fail inside a borehole, and when that happens, it's a messy situation. Rig may fail in the process, and rig replacement costs are a bigger pain for the contractor. And then we are talking about yielding of pipe due to excessive pullback. The damage is the part where we see this part right here. Am I able to highlight this? Yeah. So that was the situation that you were mentioning, where people did not take care of calculating these loads. It's actually a 2 day, not even 2 day, half a day calculation process, if we think about it. But that's where this simple mistake can cause the quality of your product. Then the underestimation of loads is where the other part is where I'll play this video of what happened in case of a rig failure. This was a rig failure situation, and mid process they had to take out a pipe using crane. Messy situations, messy. So let's discuss quickly, go over regarding the methods of calculation of these forces. There are two typical methods: ASTM F1962. This, I think these formulations are based on 2002 iteration. There's 2022 iteration as well, where not much changes are there. There's just a couple of more parametric additional conditions, nothing too special. And the other method is PRCI method, where we call it as Pipeline Research Institute. Moving on, the ASTM method is what we'll typically deal with when we are talking about most projects, and it accounts for flexible pipes where bending stresses are not very significant. The drag forces in these calculations typically tend to be function of the diameter itself. This method does not account for the length of the pipe. Materials applicable are basically, it can be designed for all flex. It can be a design mechanism for all flexible pipes, but typically best case for PE, HDPE, plastic ones. The PRCI pipes, PRCI method goes for the pipes with higher bending resistance. So when we are talking about bending resistance, we are talking about bending radius, the forces that it has to bear due to the bending loads. And then we are talking about the drag force being a function of the length inside the borehole as well. So a quick go over regarding the ASTM method. These are some design assumptions which basically go over that the pipe is flexible pipe, friction is directly proportional to the normal forces, the basic rules of physics. Tension amplifies at bends. This is the rule in physics that we learn as Capstan law, where in around the pulley we experience an exponential growth in friction when we are dealing with any cables passing around a pulley. Then we have a fluidic drag based on the equilibrium fluid under pressure at drag pipe and borehole surfaces. And bore path plan parameter is known. That's the session which was done by Mr. Aitashamul Haq. He discussed more about bore path plan. So those parameters, once known, once the bore path plan is designed, we go for the selection of the pipes and we go for the selection of your drilling rigs. Basically, this is where we discuss the operations design part. That is the project design part. We are talking about operations design part. This is a quick layout, and this is going to be the diagram of a generic HDD project. In a generic HDD project, we are assuming this is the river crossing, there can be a highway crossing, there can be a railway crossing for that matter. There's any type of crossing that we are discussing. The whole idea is that we divide this project into 4 segments, which is L1. L1 segment is basically the part where the pipe enters your ground or enters the borehole with an incline angle of alpha. The exit angle is angle beta, and then there's a descent part. The horizontal length of the descent is called as L2. The horizontal length parallel to the ground is L3, and then there's a ascending length which is called L4. These are the typical formulation parts that are essential for the design aspects. The important items for the people, the manufacturers and everyone over here are the parameters which are typically used for selection of pipes are the diameter of the pipe, the diameter ratio, that is the outer diameter and the wall thickness, the length of crossing, the straight length of the pipe, the coefficients of friction at the surface as well as the lubricated end, entry and exit angle, preferably in radians. You can convert always, there's calculators everywhere. And then max depth of the borehole in meters. Since we are doing SI units, it has to be in meters. Unit weight of the pipe in Newton per meter. Another 3 elements are specific gravity of the mud slurry, relative density, your safe pulling stress of the pipe material. Again, that's where you provide the information. Borehole diameter, typically 1.5 times the diameter of the pipe. That's a rule of thumb that industry follows during an HDD operation. So in terms of calculating these lengths, what I'll do is I'll quickly go over this. The L2 and L4, basically the ascent and descent length are formulations based on trigonometry and arc circular formations. And your first L1, the length at the entry of the pipe is assumed to be 30 meters or 100 feet, whichever unit system you're following. And then L3 is what your project parameters will dictate, which is typically the crossing or typically the design that is required for you to cross. In a lot of cases, L3 can be 0, where you simply descend and automatically right then you start ascending. So that is also a simple situation. Calculating buoyancy loads is where we talk about basic physics, your downward force versus the buoyant force of the drilling fluid. Then we are talking about different 4 zones of tension where your pipe will experience tension. Your zone A, which is the entry zone. Zone B, where the entry zone's force plus the friction and buoyancy reduction buoyancy, resistance, and other parameters come into play, and they are multiplied by the exponential factor, which is basically the angle with which it changes the curvature of the path. The same goes at tension at C, where basically your friction gets added up and your curvature at the ascending portion comes into play. And then we have tension at zone D, which is the exit zone. This happens to be the zone which will bear the most tension. This happens to be the zone where you will face the maximum amount of force required to pull the pipe outside the ground. Once you have maximum values of tension at zone A, B, C, and D, which is most likely going to be zone D, you add that force along with the drag force, which is caused by the drilling fluid. Drag force is simply this formulation, which is 0.07 megapascals times pi d square by 8 d square whole minus d of the pipe, diameter of the pipe. Then you compare that value with the allowable tensile load of the pipe, and this is the formulation for that. This typical formulation has been designed is the simple physics formula that we've learned over ages now. Safety consideration when we are talking about these when we are talking about pullback parameters, pullback situation. In mid construction, when we are experiencing this, we should also account for thermal stresses. We should also account for reduced strength in materials, PE or plastic materials. And we should also account for the loading during the process. Since we are crossing, that means your operations of the existing utilities do happen to continue without any hesitation. Post construction, the important part comes into play, which is the as-built drawings, which should be approved by a utility engineer at the maximum to make sure that the information that's out there is realistic information. This is important for your clients, for your utility owners, for that matter. The whole idea for as-built drawings to be accurate is to make sure that others don't hit your pipe. Inspection and cleanup by certified HDD operators and assessors and designers, that's where this entire post-construction process should also be maintained. Mr. Huck mentioned regarding the annular gap that's present between the pipe as well as pipe and the borehole, which requires stabilization. Those aspects are there. Your cleanup material should be environmental friendly. These aspects are very, very essential when we are dealing with operations among civilians. PRCI design basics. Similar principle follows zone A, B, C, and D. 4 zones are there. The formulations are slightly different. This accounts for the bending stresses as well as hoop stresses, suitable for steel pipes and requires multiple iterations of calculation. It's not done once. It's calculated, then revised, then changed. We change the diameter, wall thickness and diameter ratios and stuff. I'll quickly go over since it's less relevant to the current conference. Basic idea is to calculate the allowable pulling load, and then moving on to calculating the loads during the straight portion, which is going to be the frictional, drag, and weight forces. Typically, it's the friction force which changes during your straight or the curved portions. So in the curved portion, the formulation for friction changes to hyperbolic tan functions and arc length of your curvature, depending on how big your curvature goes according to your bore path plan. These are the formulations. I'll quickly skip through that because it's not used in plastic pipes. Moving on, some more resources that are there that can be used for your further knowledge, for further research. ASTM F1962 2011 is the latest version. I'm sorry, I think I mentioned 2022, but it's 2011. Then these are some papers that would be very helpful in learning more and more principles about pullback forces and pipe selections in HDD process. These are some publications that typically discuss INDSCT publications that discuss the conditions which are typically practiced in India. The code of practices are there for HDD, for subsurface utility engineering. So Mahanagar Gas, the gentleman from Mahanagar Gas I would actually recommend the code of practice for a gentleman from Mahanagar Gas. The code of practice is for SUE. And then schedule of rate is there. Schedule of rates for trenchless works are there. That's where we we invite everyone to take a look at these publications because you may find something useful for your own products. And now this is a call for everyone who's a leader, an executor, innovator, or a technician. We host an award ceremony called INDSTD Trenchless Excellence Award, which is basically a series to promote the best practices in this industry. See, this having knowledge of these technology is one thing. Applying this technology to the best of its possibility and showing it to the world is what should be rewarded. That's where INDSCT's mission to promote the best practices come into play. And this year we are hosting this award ceremony in Goa. With this, I yield my time. Thank you very much. Firstly, I would like to hear a round of applause for my fellow panel members. Can I hear a round of applause for them, please? And can I hear a round of applause for everyone over here, my lovely audience? Thank you very much, Mr. Dasgupta.
For a very lucid presentation and easy to work with formulas. Especially this subject has become very important with so much of urban installation going on where you can't work without HDD. Coming to the next paper, let me introduce the next speaker. Dr. Ajit Salvi is the Chief Engineer of Municipal Corporation of Greater Mumbai, and his topic will be use of plastic pipes for durable water and wastewater network. Dr. Salvi is working with MCGM as Chief Engineer in Sewerage Operations Department. He is having long 33 years of experience of planning and maintenance of sewage conveyance system, pumping and treatment plants. He has participated in various World Bank aided projects related to sewerage. He has involved in mega STP projects of Mumbai with provision of recycle and reuse of treated wastewater. He has implemented various projects using new technologies which include use of biotechnology for sewage treatment in big STPs. He has published various research papers. He is a resource person for subjects related to water and wastewater for various missions of government such as Amrut, Swachh Bharat Mission, NULM, etc. He has also been involved in training of engineers and elected representatives of municipal corporation in Western region for various government initiatives. He is a resource person for various management development programs. He is National Council member of Indian Society for Training and Development Mumbai chapter. He is a B, MBA and PhD. He is a visiting faculty in various technical and administrative institutes which includes Mumbai IIT, Yashoda, Pune and AII LSG Mumbai. He is a prolific speaker and I have seen him in many forums. So let's welcome Dr. Ajit Salvi.
Okay, thanks for nice introduction, Dasgupta ji. So basically, I think last 2 days, almost second days on the verge of completion, you must heard lots of things about the plastics, technologies and material and all. So definitely I will not talk about more plastics because all are experts from that. But definitely I can talk about the application part and what are the difficulties and what are the challenges what we face. And definitely you have to give the solution for that. That is what they expected from this particular presentation. So one more thing is what my slides will have lots of data, lots of other things, and I can discuss so many things related to, because water supply and wastewater is of interest of everyone. But my presentation, I will try to restrict related to plastic pipes, and other things I will try to omit, and or other I will not discuss more in detail. That is what expected. So this is a slide actually I wanted to show. Ki if you see on the very left hand side, maybe somewhere in 1600, Mumbai city was not there as such. Only islands were there. Why I am specifically showing, ki if you compare with the other cities like metro cities, maybe Chennai, Bangalore, Delhi, or all other cities, they were existing since, say, you can say 1000 years back, 1500 years back. It was not the case for the Mumbai, and it is finally formed by just lots of other work was done, and then the city was formed. And that is the reason you will find that when islands are connected, when you go for the infrastructure project, when you go for the digging, lots of problems are also there. It is very simple to say, ki, go for the infrastructure, go for the other solutions and all. But in Mumbai, compare with the other cities like Kolkata or Delhi or Chennai or even Bangalore, you just dig for the even 5 or 10 feet and you will find there is a lots of water available. So water table is very low, and these are that creates the problem. I am just connecting with the pipes, nothing else. So this is, so with this, the background of the city, and it is not a so old city, maximum 300 or 400 years back, that's it, not more than that. Now, talking about the some water and sewerage system of Mumbai, as I said, ki lots of inputs are there, but if you concentrate on the highlighted part, that is in red, you will find that we are supplying almost 3850 million liters of the water every day to the Mumbai, city of the Mumbai. Say, even as a part of curiosity, if you do the calculation, and if you find, if just compare with the population and water supply, you will find that it is more than sufficient. It is more than sufficient. Then where is the problem? I will come to the problem later on. So that much water is supplied, as against length of the, say, water mains is around 4,000 kilometers. So this is the conference of water pipes, or say plastic pipes. Definitely it is of interest. It is of the interest. This particular data is very important for you. Now, from the wastewater side or from the sewerage side, you will find that because of the slums are there, lots of unauthorized, unauthorized hutments are there, still 30% of the area is unsewered. Still it is not sewered. So definitely he was talking about some pipe laying and all. So lots of scope still it is there, because still 30% area is not sewered. Another thing you will find that whatever sewer line, if you see the history, it is almost 130 years old. Britishers laid the initial sewerage system in Mumbai somewhere in 1880. That much old system is there. So if it is an old system, definitely that will not, we cannot continue with the same system. So we have to either go for the replacement or we have to go for rehabilitation. Definitely we opted for the second option, that is the rehabilitation with the trenchless technology. Swaroop has rightly pointed out. So that was the option what we selected. And when you go for the trenchless technology, again the first option is what? Plastic, nothing else. First option is plastic. So that is what again a good thing for you. So that is the thing. As I said, I can talk so many things, but I'm just restricting. If you see the sewerage network, it is also at this stage it is more than 2,000 kilometers. And again I repeated, still 30% area is unsewered. So still it can go higher, and maximum it can go up to 2,500 or 3,000 kilometers. That is what possible. So with this particular background, we can still move further. Now when you talk about, I will just be talking about water and wastewater, and particularly the network, the conveyance system. Generally in case of Mumbai, you will find that there is no water supply inside Mumbai, and we have to bring all this water all the way around 100-150 kilometers away from the city. So that is what I have shown various dams which are located somewhere out of the city, almost 100 to 150 kilometers. So that much water has to be transported inside the, say, city, and that is a huge sort of a exercise we have to do. This is just for the interest, how we are, say, you will find that there is a Batsa dam is there, then there is a Pise pumping, Pandrapur water treatment plant, then Vaitarna, middle Vaitarna, upper Vaitarna, so many things are there. Tulsi and Vihar, everybody is aware about Vihar lake and all. And then there is a Bandup complex. You can see that arithmetical part, something that is what 3853 million liters of the water is supplied. Again, When I say 100 to 150 kilometer traveling is there, again it is piping, nothing else. Again it is piping. Nowadays we are going for the tunnels also. We are going for the tunnels also. But otherwise, majority of the say transportation, majority of the conveyance is done by the piping only. So again, say if you see overall Mumbai water supply scenario, there is a source, maybe river or something. There are some reservoirs, then distribution mains, service mains, and then consumer connection. In a simple way, I can say there is a primary network from source to say maybe to the dam. Then from dam to the reservoirs, there can be a secondary secondary network, and from reservoir to the consumer, that is a distribution, or you can say tertiary network is there. So this is how the things are there. Again, length of the water mains around 4,000 kilometer, number of distribution 109, leak detection zone 615, and daily operated walls are 800. Now that leak detection zones are important for you, I will speak later on about what is that leak detection exactly, why it is required and why it is important. So this is how the overall things are operated. Now, so far challenges are concerned about the Mumbai water supply. This is the slide. I can talk at least half an hour minimum. This is possible, but I will be focusing only on the red part, but just go through basically quantity of water. Everybody is interested, I should have a water, sufficient maximum water. So there is a problem. Some of the places you will have a sufficient quantity of water is available. Some of the places they are facing some difficulties. Then there is a quality of water is also important. Though you must be reading in the newspaper or in the media also, various media, Mumbai's water supply is supposed to be considered as the best so far quality is concerned, and it can be compared with any of the international standards. Issues pertaining to hours of the supply. So wherever, particularly in the city, the old city of Mumbai, still it is supplied the water at the because chals are there, hutments are there. So every 2 hours, 3 hours water is supplied. Some of the places even at 1.5 hour water is supplied. Then I will talk about the issue pertaining about the non-revenue water. This is important. So this non-revenue water, that means what? Ki basically there is a physical and revenue loss. So, and it is almost 30 to 35%, sometimes it is more also. And you can take it from me, if you consider entire city or entire India, it is always more than 35% or 40%. So that is a non-revenue water. Basically, it is some of the theft is there and some of the water is what? There is a leakage is there. Now again, so far this particular forum is concerned, we are more interested in leakage part and we have to arrest that. I have a separate slide for that. So this 30 to 35% when I say NRW is a huge quantity. Just consider, I said our water supply is 3850 million liter per day. And if you just compare 30% and that much, even Chennai's water supply is not there. Chennai's water supply is not there. That much supply is not there. And that is just we are wasting as a NRW. Okay. So this is the point, challenges we have to address. And this forum it's for that also. One of the aspect or one of the objectives is that also. Issues pertaining to the cost of the operation and tariff structure, lots of problems are there. Everybody wants water at a free of charge or subsidized rate. That is again a big trouble. I am just avoiding that discussion here. Now, leakage. Now just see, sometimes picture is worth 1,000 words. So this you can understand how it is happening and how much liters of the water is wasted whenever there is a leakage and whenever there is sometimes it is what intentional also. Some theft are there. Some part of the society they are doing that also. So that is what is happening. You can see the challenges in what protection of water mains in some part of the city. This is nothing but what Mumbai and how to protect that supply. Then that is the problem. So you can think about quality also, you can think about leakage also. So not a easy target. So though we are treating up to the good standard at our treatment plant, but when it is passing through the hutments and all, there is every possibility of what pilferage and all other say quality aspects are also what are in trouble. See, higher water mains, now you see the distribution mains. So this is how the water pipes are passing, and sometimes you can now understand how leakages are happening, how thefts are happening. It is not, sometimes it is not metered, how I'm talking about the tariff and all. Anyway, forget all this aspect, just focus on what, how to address the leakage, how we can replace this pipe with the better material or leak-proof material. That is what the point. And I wanted to put this aspect in front of you. Now, after talking some part about the water supply, let us focus on sewerage also. This is the Mumbai, and Mumbai's sewerage zones are, we have divided into 7 zones. Without going into much more technical details, I just wanted to tell you, so this everything was done somewhere in 1772. So that is what, that much we are advanced. Everything was done with full design and all. So that was done with the help of, aid of World Bank and all. And accordingly, the sewerage system is designed and laid. So this is general layout. You will find that water distribution is there. So water, say water works is there. Then there is a reservoirs, and then there is a distribution. And on the other side, when you talk about the wastewater, there is a industries are there. Then households are there. Then transportation, treatment, and finally again, it is what, discharge. My point is what, every day water is supplied 3850 million liter per day. After considering NRW or theft or leakages, whatever water is supplied to the city, next day it is converted into wastewater. So both the system we have to keep in operation. One side there is a supply of the fresh water, on the other side immediately there is a treatment and disposal of the wastewater. That is to be kept in operation. I will tell you that the wastewater side is more complicated and more difficult, because there is no reservoirs for the wastewater. There is no dams for the wastewater. It has to be operated 24/7. There is no mega block for the wastewaters. Not allowed. It is allowed only for railways, not for us. So there is no mega block, there is no reservoirs, there is no dams. So that particular part is not so easy to keep in operation and maintenance. That is a difficult task. And again, so majority of the part is what? Conveyance system. That is what? Pipe work. Material is another. That is what we can discuss it on. So this is how the general thing about any city is concerned. But so far Mumbai is concerned, as I pointed out with the help of statistical data, it is a huge comparatively. Now, just as a matter of fact, this slide I just put in for understanding that pipe is not new. It is, say, you can see the history. From ancient civilization, there was somewhere in the lead pipes were there, aqueducts were there. In medieval period, it was some lead, iron, and even in some of the places, wooden pipes were also there, particularly for carrying the wastewater also. After industrial revolution, cast iron pipes comes into picture, and then 19th and early 20th century, steel pipes, GI pipes are there. Then mid 20th century, it is of your interest, that is what PVC pipes are there, and other ABS pipes are there. And in modern area, still more improvement in the plastic side, the HDP pipes are also there. This is only for indicative. So many other materials are also there. It is only just indicative. How the things are changing and happening, and from say metallic pipe or wooden pipe, slowly we are going towards what? Plastic pipe. That is how I wanted to show, nothing else. Now, just I'm not focusing more on this particular aspect. Just only one slide I will be talking about, maybe half minute. So if you talk about the cast iron pipes, which are, you can see that maybe in 100 years back, this was very common. And even you'll find that in some of the places, the cast iron pipes are used, particularly whenever there are pressurized mains are there. It is a very durable and long lasting, and you will find that some of the installation are lasting over a century. It can, if it is there, we can reliable for that particular thing. And old part is also in operation in a good way. But on a disadvantage side, you will find cast iron is a brittle, heavyweight, making handling and installation is a labor intensive, not easy thing. So this is what the comparatively old material. If you go on a, say, metallic side, ductile iron, still it is a higher strength with a durability suitable for high pressure application. Say, I'm not comparing with directly with the cast iron, but in comparison, there are so many other advantages are there. But from the disadvantages side, you will find that they are higher in initial cost, requiring specialized equipment for handling and installation. But definitely you'll find that as a replacement to the CI, in some of the places we are going for DI also. And there is a one more aspect for this also there, particularly when you talk about a CI, it is a attraction for the antisocial element for it has got a good scrap value, which is not so in case of DI. So that is also one aspect, particularly when I talk about the sewerage side, this aspect we consider. Then very commonly used is what? GI pipes. That is what very commonly. That is very traditionally it is used and having lots of advantage. But on the other side, you will find that there is a corrosion, scaling is there, weight and installation difficulty and maintenance problems are also there. So that is what about the GI pipe. Now with this, I just wanted to spare 2 slides to show about what are the government initiatives. Say you will find that in 2019, our Honorable Prime Minister talked about the Jal Jeevan Mission, that is what Har Ghar Jal, very important and very ambitious project. I wanted to tell that when you talk about the Har Ghar Jal, okay, or say it is expected that timeline is by 2024. So by this time, majority of the part is done. I am not saying it is 100%, but when you talk about the Har Ghar Jal, that means what? It is to be it a pipe water supply. It is a pipe water supply. And when you talk about the pipe water supply, so main aspect is what? You can see in the last line I talked about that Maharashtra Jeevan Pradhikarana. You talk about the state. Why their circular number 257, they have allowed use of various plastic pipes depending upon the site condition. See, as I say, it is not like that the plastic is a lots of advantage and you can use anywhere. It is not so. But they have clearly stated, considering the site difficulties, site problem, depending upon that condition, definitely you can go for the, say, use of plastic pipe, whether go for HDPE or go for, say, UPVC or go for PVC, that has to be selected based on the site condition. So this is a very interesting movement done by the Jal Jeevan Mission from the, say, state government. There is one more scheme, that is what Atal Mission for Rejuvenation and Urban Transformation, and we call it as what Amrut. Again, there are so many aspects are there, but one of the important aspect of this particular mission is what? Water supply, sewerage and drainage. Again, now just imagine, when I talk about the water supply, sewerage and drainage, again it is a pipe network. Pipe network. And pipe network is there. Already I have shown how the pipe technology or material is changed from slowly we are moving from metallic to the plastic pipe. Okay. So that is what. The government is also taking lots of initiative in that particular aspect. So they are going with the initiatives for water, drainage or wastewater. Material, we have to provide a good type of material because there are some limitation with the PVC. There are some limitation with the other material. So we have to overcome that and we have to go for the good material. This particular thing, I was talking about the NRW. In some slide, I said it is 35%, around 30 to 35%. So this NRW is a big problem. It is not Mumbai for anywhere, particularly in India. If you compare with the, say, Western cities or developed countries, their NRW is 5% or 10%. And our NRW is what? 30 to 35%. Lots of leakages are there. Now this is the point where we should address. And I have, as a part of a theory, I have mentioned strategies to reduce the NRW. But I would like to highlight the first point. That is what? Leak detection and repair. That is the main. Other things are okay. They are there. But if leak detection and repair are there, everybody can understand what is the reason. And I can show you by some other further slides how the leak detection, what is the problem, and how that material has to be replaced by suitable plastic material. Say, as I said, you will find that majority of the case we are using GI pipes, okay? And GI pipe is a very common. Even at your, say, you see the drainage, particularly pipe network in your buildings also. The lots of GI pipes are used, in olden days. But how slowly we are replacing with the, say, plastic pipes. What is the problem with the GI pipe? No doubt it is good, but lots of corrosion problems are there. Joint failures are there, physical damage and pipe wear and tear are there. So this is, say, I think again, that photo is sufficient. Everybody must have seen that. If you remove all old pipe, maybe around 10, 15-year-old pipe, and these conditions are there. Those who are staying in a cooperative society, it is a common problem. They are saying that pressure nahi aa raha hai, pani ka pressure nahi aa raha hai. problem हो रहा है. So that is what. And then over a period of time, you have to go for replacement of the entire that pipe network. So this is what the mainly the corrosion aspects are there. Then there is a joint failures of the GI pipe. So that is also very common. Wherever joints are there, if it is not done properly, because of the corrosion, because of the poor installation, that joints are failed and lots of leakages are happening. So that is also one of the aspect. Physical damage and wear and tear of the GI pipes are also there, and these are the difficulties, and we need to make sure that we have to replace that. Addressing the leakage in the GI pipes and water supply network. How to, I talked about the problems, difficulties in GI pipe. What is the steps? What is to be done? Again, I have, as an engineer, I have stated so many solutions, but let us concentrate on last line. That is what? Replacement and rehabilitation. Okay. Either go by replacement with the good material, improved material, or do the rehabilitation in case of it is a big size pipes. That is what the Sarupji was talking about. Okay. Now replacement, and that is what by either by PVC pipe or SDP pipe or BWSC pipe. These are the general indicative examples I am telling how you can do that. I think no need to talk about what are the advantages and disadvantages of the PVC pipe, because everybody is aware. I am just going ahead. Then it can be HD pipe also, and similarly for the BWSC pipe. So these are the replacement aspect possible, because there are lots of wear and tear, corrosion problems are there in GI pipes. When you go to the wastewater side, these are the old pipes. That is mainly either stoneware pipes are there, and somewhere in a new case, comparatively new case, it is a concrete pipes are there, cement pipes are there. Now, when we did our CCTV survey of our all drainage network, he was talking about CCTV survey. So this is what we found. There is a cracking and breakages are, root infiltration is there, corrosion, sedimentations are there, joint failures are there, scaling and deposits are there, temperature sensitivity, and age-related degradation. So in the olden days, there was no other options available, and that is the reason that stoneware pipe was the only solution. But we find that over a period of time, it creates lots of difficulty, lots of problem, and I have just tried to highlight. Actually, in other slides, I am talking about what is the reason and all, but let us go ahead, and I would like to show you. These are the different reasons why that stoneware pipes are making difficulty. Reason, age-related degradation in the stoneware and concrete pipes. Again, solution is what? Likewise, I shown you the solution for the water supply. Now, wastewater supply, whenever there is a wastewater pipes are there is a solution. What is the alternative solution? Either you go for pipe relining or CIPP pipe, that is cured in plastic pipe, pipe busting, he has shown pipe busting. There is a slip lining, spray on lining, PVC or SDP pipe replacement, and traceless excavation and replacement. So you can see that all answers are nothing but what? Plastic pipes. Nothing else. Okay. Nowadays, or trenchless. Nobody is going by open cut method technology. At least for the sewerage is concerned. If it is a rehabilitation, we are not going by open cut method. We are going by rehabilitation, trenchless technology, and majority of the plastic pipe. I can show you the more details also. See this particular table, you will find that see how various technologies what we use. That is what pipe busting, that is what fold and form method, CIPP method is there, and CIPP with the UV lining, and then MWSL lining is there, geopolymer is there, GRP lining is there. Now, as you are of the interest, see the material, and all material are nothing but what? Various grades of the plastic. That's it. Various grades of the plastic. And you see on the right hand side, whatever the old network is there, out of that almost 96 kilometer of the network rehabilitation done with this type of various technology. And proposed work, we have invited the tenders for the proposed work, and in which we have taken in the 97 kilometer of the network. I was talking about Britishers laid the network somewhere in 130 years back, and the same network we are using by using this trenchless technology. Same network, that is what. So we are not going for the new network, we are not going for the scrapping that network and going for the new, but rather than we are using the same line, but with the help of trenchless technology. And when I talk about the trenchless technology, there is no answer, but only one answer, that is what? Plastic pipes, in a one or different form, nothing else. Now, say, from government side, there are two indications are there. Again, it is an interesting thing. See, on the left-hand side, I have highlighted that extent of the non-revenue water should not be more than 20%. That is what they say, more than 20%. So, as against we are saying 30 to 35%, say they are not directly comparing with the Western countries like 10% or 5%, at least go for the 20%. So, for that purpose, again, we have to go for replacement of the network, pipe network. And when you talk about the replacement of the pipe network, again, there is no answer but the plastic pipes. On the right hand side, you can see that, again, I have highlighted one point, that is what? Extent of reuse and recycle of sewage, that is what? 20%. Now, this is also interesting. I can show the further slide. The recycle and reuse is what? Whatever wastewater is generated, we have to recycle it and we have to reuse it for non-potable purposes. That is what the guidelines. So government says that at least 20% should be recycled and reused. Now these are our plans. You can see on the right hand side, I have given the target date also. So it is from April, June 2022, and then number of months are also there. So you'll find that all plants will be ready by 2026 or 2027. You see on the fourth column, recycle and reuse capacity. Government set the target of 20%, but we have set our target as 50%. So whatever treated wastewater is available, 50% will be used for the recycle and reuse purpose. Now, again there is one opportunity. If 1,271 million liter of the treated wastewater is available for non-potable purpose, but that will be available in our plant, we have to take it to the consumer. We have to take it to the industries. How to take it? Again, by laying the pipes. Which pipes? There is no solution. Plastic pipes. Okay. So this is what. Now, interesting part is what? Still we are not, conversant with the recycle and reuse of the treated wastewater and all. But I can show you in, our Swedish consultant, they have converted wastewater into beer. Very interesting. And so some of the participants, they always tell me, sir, ऐसा कुछ बनाओ 31st December को पूरा खत्म कर देंगे. And this is not the picture I have taken from the Google and all. This is the actual photograph, and they have just presented to me, and I have taken it for my academic purpose because I am everywhere I am talking about recycle and reuse of treated wastewater. So there is opportunity for you. There will be 50% recycled or treated wastewater will be available. We have to take it to the good industries, good bulk consumers, and how to take it by laying the good pipe network. That is the opportunity possible. So with this, thank you Chanchalji for Dasgupta ji for giving. Thank you. Thanks a lot.
Thank you, Dr. Salvi, for covering a lot of ground, but still keeping within your 30 minutes. And it was really, entertainment with knowledge. Now let me introduce the next speaker, one of the most experienced speaker in this conference, Mr. Agam Mathur, who is a water sector specialist and ex-chief engineer special projects in the PhD Rajasthan. With over 4 decades of extensive experience in the field of water supply and wastewater management, he has demonstrated a rich professional journey from serving as an assistant engineer, rising to the post of chief engineer in Rajasthan PhD, to his current role as an independent consultant and director at Saraswati Technical Services. He has undertaken various responsibilities including conceptualization, design, proposal preparation, award, implementation and monitoring of significant water projects. His diverse training background ranging from water supply and sewerage projects to economic analysis, computer-aided design and PPP projects reflect his commitment to staying updated with the industry advancements. As holding different posts till the chief engineer in PhD Rajasthan, he oversaw major rural and urban drinking water supply projects and played a crucial role in interdepartmental coordination and policy formulation for public-private partnership. His contributions extend to working with international organizations like the World Bank and ADB, showcasing his global perspective in water resources management. His expertise lies in optimizing costs, financial analysis, and detailed engineering services for EPC contracts. His dedication to the sector is evident in his continuous involvement in workshops, forums, and training programs, underlining his commitment to professional growth and knowledge dissemination. With this introduction, I'd invite Mr. Agam Mathur for his topic Challenges and Mitigation Measures in Implementing 24/7 Water Supply Services. For you, sir.
Thank you, SPE, for inviting me and allowing me to share my ideas on challenges and mitigation measures in implementing 24/7 water supply. As a government servant, I had an opportunity to work closely with the bureaucrats and the politicians while dealing with the urban and rural water supply systems. The problems we faced, the suggestions we made, and some successes we had, and some successes even with best of our efforts we could not have. So safe drinking water is the basic need of human life, only next to air. Presently, all the urban towns in India are covered with public water supply systems, but almost all of these are operating on an intermittent basis. Now, when I was invited for this conference, I thought, what is the context for me to talk? So, plastic pipes have an important role to play in solving the drinking water problem per se. Right now, we are doing a drinking water supply project in Jaipur, kind of a new colony, it's a greenfield project. So, the breakup of pipes in the network, I've just put in the data. The length of pipe in kilometers, HDP pipe is 2,400 kilometers in 46 zones, and DI is only 333. So in Rajasthan, in urban and rural projects, the share of HDP pipe is around 90% or higher. So doing the HDP pipe, quality pipe, and its laying one time right before it goes underground is very, very important in providing safe drinking water to all the public, urban and rural. Now, what do the consumer expect from a water supply? It should be portable, reliable, adequate quantity, adequate duration, adequate pressure, affordable, consumer-friendly complaint redressal system. But there is no demand from the public for a 24/7 water supply. I think, like for electricity, we, of course, in urban areas, we have a demand that 24 घंटे बिजली आनी चाहिए. But in urban houses, we have sumps, we pump water on the overhead tank, and we have a 24/7 water supply in our kitchens and in our bathroom. So public water supply, there is no pressure from the public. There is no target from the politicians to convert the systems. What is the existing status? Coverage in peripheral areas remains uncovered. Reliability, intermittent supply and unequal distribution. Duration is half an hour to 3 hours per day. And at odd timings when you do a zoning, sub-zoning. Pressure is low. Required household level storage and boosting when the pressure is low. Problems of pollution in pipeline in the intermittent supply system. Interface with consumers need improvement. High coping cost at the consumer end. But if we have a 24/7 supply, it can solve most of the problems. World over, countries having well-defined water sector policies and proper institutional setup have 24/7 water supply in the urban towns. In the water supply manual, in the old manual as well as in the new manual, it recognizes only 24 into 7 water supply. There is nothing like intermittent water supply in the manual. All the new systems which we design and reorganized systems, we design them on 24 into 7 basis, considering the peak factors for a 24 into 7. Then why the water supply systems don't perform? And what are the challenges that the water supply systems don't perform on 24 into 7? So I have tried to categorize these challenges in like technical challenges. Water availability is a challenge, financial availability is a challenge, institutional setup is a challenge, community and cultural issues, then there are political issues. Technical challenges, as my previous speakers have spoken, high leakage and unauthorized connections. Means we call it non-revenue water. It has two components basically, a technical loss and a non-technical. So technical is the physical loss of water which doesn't reach the consumer, and non-technical or commercial loss is one where the water component reaches the consumer but we are not able to bill for it. So these are two. So a typical NRW survey was done some 15 years back in one of the towns with a foreign consultant, TCE. So we found that 25% is the physical loss and 15% is the commercial loss. And then most important challenge and the problem is that the consumers draw water in their sumps, underground sumps. When we open the valve of the distribution reservoir, the water flows from the reservoir to the underground sumps. And that is the biggest challenge in our intermittent system, cause of the intermittent system. And then non-availability of updated maps. My previous speaker had also spoken from Suez that there are no records available. If you are going to find out leakages, we don't know where the pipes are laid exactly. Absence of quality technical proposals and contract documents. When we are awarding contracts, when we are preparing EPC contracts or maintenance contracts, we do not have maps which we can hand over to the contractor or to the maintenance agency. What kind of pipe, what depth, what location, the valves and everything. Lack of required skills in the technical staff and engineering staff within the department in dealing with these issues. Lower focus on demand management. This is another one thing which is very, very important. Our engineers and our politicians, bureaucrats, they are interested in providing new water sources, new water treatment plants, new pipelines. But the demand management, like issues of metering, issues of leakage removal, issues of tariff rationalization, this is not being attended to. Now, what is the problem? We design a system, this curve on the top side shows for a 24 into 7 supply on which we base our design. Here, the peak demand during day is about 2.5 to 3 times the average demand on which we design the system. But when we supplies are made in 3 hours only or 1.5 hours, the peak factor is like 12. And a typical distribution system, the head loss or the pressure drop is like 2 meters per kilometer, which rises to 26 meters per kilometer, and the result is the pressure drops immediately after the reservoir, and within 100 and 200 meters the low pressure zones start due to very high demand and heavy head loss in the initial pipes. And then water availability, I'm talking particularly in Rajasthan. We have like 220 towns and we are bringing water from a long distance. For all major towns, we have been able to increase the water supply availability. And you would see that the first 12 towns have water availability of 160 liters per capita to 277 liters per capita, and next 13 towns 135 to 156. But only 7 of the 12 towns have a daily supply, and 8 of the 13 towns have daily supply, and remaining towns have alternate day supply. This is purely on lack of demand management. Remaining these towns cover around 50% of the total urban population of Rajasthan. 197 towns have availability of water less than 135 LPCD. So demand management is a huge problem and the basic requirement for converting intermittent to a 24 into 7 supply. Then the institutional challenge. Our organizational setup per se, maybe for different states, other PhDs also, we are basically a public works department. As the Suez, the engineer from the Suez said, we do not work as an operator, but we work as a as a construction department, and our contractors have a mindset of a construction company only. So there's a huge problem. Absence of cadre required for qualify and specialization for non-revenue water reduction, for accurate mapping, for record keeping. So that's a problem. Lack of autonomy and accountability. Even for small repairs or even for small things, the file or the budget requirement has go to right up the top, and the sanction trickles in late. So stationary time saves 9 kind of thing. We are not able to do. So the manager at the town level, the manager at the town level should have the autonomy to take up the repairs and they do required things. Now, another point is lack of appreciation of the sectoral issues at the decision makers. What is decision makers? Is the bureaucracy and the politicians. Lack of collection of primary operational data and performance reporting. What we are reporting is number of connections made, length of pipeline laid, number of reservoir done, but we are not reporting, at least in Rajasthan, I don't know about others, what is the daily production, what is the water quantity actually going to the consumers, what are the pressures available in different zones or DMAs. So that reporting is absent. Financial cost recovery is only 30% of direct O&M cost and only 21% of full cost. So full cost would include the financial cost also. So we are recovering only 21%. Overall inadequacy of funds for capital works and improvement works. Available funds are allocated on priority to new capital works, lower allocation for non-revenue water reduction and performance improvement works. So this breakup shows the O&M expenses versus revenue in Rajasthan urban water supply systems. So the total O&M expenses last year were 1,622 crores and the revenue was only 495 crores. So only 30%. Now if I add the cost of depreciation and debt repayment only for part of the fund, otherwise we have considered almost 90% as grant. So it is only 21%. So we have to depend totally on the budgetary support. And therefore we are not able to plan the improvement works. We are not able to plan the required efficiency measures. Political. Lack of support for change in institutional setup. We have had a lot of consultancy reports by the World Bank consultants, the KPMGs, the Deloittes, everybody saying that you have to change your organization. You have to have specialization, you have to have positions of customer requirement, you have to have position of different tasks. But it's very difficult for the bureaucrats and especially the politicians to understand this requirement. And we continue to work as a construction department, as a public works department. Second is resistance to tariff rationalization. that is basic to demand management. Now, the competition is on providing free water. So my passion and my argument is that converting 24 into 7 is not a rocket science. We have done it. I'll come to that slide also. Lack of understanding of the sectoral issues, little time spent on understanding the issues and accepting the recommendation of the sectoral experts by the politicians. Lack of engagement with the media and community on water sector related reforms. So these are basic challenges. We theoretically we know what is to be done, but we have not been able to do things. Community and cultural. Now, there's a lack of awareness on the 24 into 7 intermittent water supply. Now, in absence of a 24 into 7 supply, what are the coping costs a common consumer is bearing? On coping costs borne by the consumers, capital cost on creating storage, underground storage, capital cost on creating cost of reboosting underground sump to rooftop. Now, the average power consumption is 250 rupees to 500 rupees per month. That consumer is ready to bear. But when it comes to raising tariff, they look otherwise, or the politicians make them look otherwise. So capital cost and recurring cost on UV and RO. Every kitchen has now a UV or a RO. Cost of getting water through transportation when the water supply is not available. Cost of treatment of illness caused due to polluted water. Now, these costs, I have worked out details from different houses and from my family and friends. This works out to 600 to 700 rupees per month on all these costs. Now, when you count of coping cost, this coping cost for poor family as a percentage of total monthly income is much higher as compared to what we well-off people have. It may be like 0.1 or 0.2 or 0.5%, but for a poor guy, it might be 6 to 10% of his monthly income. But still, there is no pressing demand from community for a 24 into 7 water supply. We have made efforts in different towns, like my friend from Suez has said, Maharashtra, Hubli, Dharwad, Jamshedpur, other towns, and in Rajasthan also, a lot of towns we have very good contracts where 100% pipelines have been changed and new water supply system have been installed. The non-revenue water has been brought less than 10%. Some towns it is like 7% or 5%. Still we don't have 24 into 7, even though the water availability is 150 LPCD. Because in absence of demand management issues, like tariff is still very low, the people are still drawing water into the sumps. Therefore, we have not been able to convert them to 24 into 7 with a low non-revenue water and water being available. But I can tell you, 20 years back or 25 years back, we had implemented a rural water supply scheme with 40 liters per capita, and the scheme ran successfully on a 24 into 7 at 40 LPCD. The water was drawn, was provided on the public stand post, and the community was involved in maintaining the systems, and there was cost recovery also from every household, and the village volunteer collected the money and handed over to the deposit in the bank. The community had formed a village water and management committee, and they were maintaining the system. Then came the political pressure, and the people were allowed to put illegal connections and draw water in the home and sumps, and the system collapsed. So it's not a rocket science per se. When I was chief engineer, we converted a few of our zones, pilot zones, and with the AC pressure pipes, we installed meters in zones of pilot zones of 500 connections. We had some 4 or 5 zones, And I noticed that we brought down the NRW to 20% with AC pressure pipes and no special measures. And the peak factor was brought down to 2.2. So it's not a rocket science. But then the water consumption on the higher income group side was about 250 liters per capita. So we could do it only for a limited number of houses. And in the flats, the consumption was only 100 liters per capita. So it all depends. If we are able to raise the tariffs and control the demand, control the leakages, and motivate the community not to draw water into the sumps, the systems can be converted from intermittent to 24/7. So when we talk of mitigation measures, to me it appears that on top of it should be the community awareness to create demand for a 24/7. We have to tell them how much expenses are you incurring in absence of a 24/7, as I detailed earlier. Implement institutional reforms and tariff reforms with political support. Digitalization and integrated management of information systems. Preparation of high quality proposals for improvement works and performance based contracts. It should be a level playing field contract, not kind of one sided. Design and impart appropriate training and skill upgradation. Create success stories and replicate them on a large scale. So, my close to my chest is the tariff restructuring measures and demand management. Control on demand, improvement in water use efficiency at the consumer end, improves financial stability, improves overall efficiency of the water supply system, promotes use of recycled water. Now, in my state, the highest domestic water tariff is only 6 rupees per kiloliter. Now, if the recycled water costs me 10 rupees, then who's going to buy it? I'll show you. This is the tariff structure. More than 40 kiloliters is 5 rupees 50 paisa, starting from 1.72 rupees per kiloliter. Absence of any policy per se for tariff revision. Tariff increases with long intervals, revisions ad hoc and small. In Rajasthan, last revision took place in 2017. Uniform tariff throughout the state. Domestic tariff is this much. Now, what happens when you have a low tariff? A poor house you seeing on the left side consumes only 9 kiloliters. It's a single tap house. So it gets a subsidy of 149 rupees. Whereas the second house you see, they are using water for washing cars and putting water in the lawn outside their house. They are consuming 100 kiloliters and getting a subsidy of 1500 rupees. These are actual figures. My production cost in Jaipur is 22 rupees a kiloliter, and we are supplying them water at 5 rupee 50 paisa a kiloliter. So they are getting this much of subsidy. In Udaipur, where water is being brought from still more distances and lift is more, it costs 30 rupees a kiloliter, and this guy is getting a subsidy of more than 2000 rupees. So it is ridiculous. There should be a cap on subsidy. Like we have a ration distribution on per capita basis. So what I propose is the tariff should be on per capita basis, and there should be a count of number of persons in a house, so that what is their eligibility of getting a subsidized water should be known, and for the remaining quantity they should bill for the actual or full cost, or with cost with some rate of return or punitive cost. What should be the abstract level type of thinking? A safe drinking water is a social good, but only up to lifeline consumption levels. Not that for if you are consuming 100 kiloliters, you get the same rate. So what is important is we define a lifeline consumption level, then define affordability. Who really needs subsidized water or free water? define economically weaker household so that we can target our subsidy. Beyond lifeline consumption, safe drinking water be considered as an economic good and priced accordingly. But we cannot charge the cost of water which is being produced and delivered inefficiently. For the present, if we are running our pumps with energy efficiency and if we are bringing the NRW within, say, norms of 15%, the cost of water can be brought down by minimum 30%. So let us say what would be the cost of water. Like Jaipur, it is 22 rupees, so it gets to 15 rupees. So at least we start charging 15 rupees. So question is, what are the underlying reasons for intermittent supply in India? Technical constraint, lack of human capacity, financial, cultural, political, historical, or water scarcity? Answer: the institutional framework. That's the answer. The technical, organizational, financial difficulties are symptoms of a wider problem. A good institutional framework is one which promotes good governance and overcomes technical, human resources, and financial and cultural difficulties. Then question, why is it that water utilities in some countries perform better than in other countries? Water abundance, technical capacity, quality management, financial resources? Answer is the institutional framework. The common ingredient to all successful organizations is that they operate within conducive institutional. Friends, Israel has a water availability much less than that in Rajasthan. Still, their per capita supply is much better. Their water services are much better. Many of our politicians and bureaucrats have toured Israel, but they have not courage to take the reform measures so far. I don't know about other states. What it could be, the organizational setup, and now we are talking of direct cash benefit, like LPG cylinder, the villager has to, the poorest of the poor has to buy at the market price, and the difference is passed on to the customer directly into his bank account. So on this philosophy, while I was in office, we had proposed this, and still it's been pending, that the bulk water supply should be a separate company, and the water distribution, the retailing of water should be a separate company, state-owned companies, and the bulk water company should charge full cost to the city company, and city company should provide to the consumers on efficient basis the services and provide the bill of the full cost. Now, as I discussed earlier, we can have norms for selecting people who need subsidy or who need free water. And since we have done a consumer survey and we know that in this house only 3 people live, or this house 15% live, so if you decide that 100 LPCD or 70 LPCD is a per capita consumption, lifeline consumption, so for that month his entitlement of subsidized or free water should be that much, and if the consumption is more, the remaining cost should be borne by him, and the subsidized cost subsidy should be given from state government directly to those targeted consumers, and there should be regulatory agencies. So this kind of structure can improve the efficiency of the bulk water system, can improve the efficiency of retailing, because they'll have to publish data, how much their water they're giving, how much water they are distributing. Now, for bringing in this kind of a model, what we really need is 100% consumer metering and reliable meter reading. It's not that, I was talking to other colleagues also, under Amrit we have installed lakhs of meters, but there are no meter readers. And even if there are meter readers, they are not reading the meter actually. They're filling the, so there's a solution. There's a solution by photo billing. There's a solution of spot billing. Those kind of things we have proposed to the government. But it's taking time for them to understand and implement things. Now, close to my chest is this integrated information management system. Now, in a water supply system, what we have is a asset data, we have operational data, we have revenue data, and we have customer data. Now, if we have implemented a DMA system and my DMA meter reading is going to the IMS server, and if my billing data and if my customers to a DMA link to that DMA are giving data to the IMS server, I can on monthly basis work out what is the non-revenue water. And these are the inputs, green ones are the input from the top, and the bottom ones you can calculate the energy efficiency, the water bills, the hydraulic model, O&M and non-revenue reports, complaint redressal data, asset register, updated maps. I have even prepared a technical report, got it passed as a consultant, and prepared the tender document. It was approved by Chief Secretary, but the department did not float the tenders. They were more interested in construction contracts and were not interested in this. Achieving 24/7 supply in Indian town is a complex task, but not unattainable. The blend of technology, community participation, and proactive governance has shown positive results in various towns. The journey towards continuous water supply for all, though challenging, but we can convert the challenge to an opportunity through out-of-box thinking and a unique approach. Thank you.
Thank you, sir. And we have more or less finished the session in time. Maybe there is time for one question, and then we break for coffee. Who's the lucky questioner? Okay, yeah. Can we get the mic, please?
So I'm Praveen Agrawal from Polyraj Pipes. I just wanted to ask you if what is the future of Jal Jeevan Mission projects in India currently? What we understand is that it is the final target is 100 liters per person per day, and currently it is being designed at 55 liters per person per day, if I don't have my figures wrong. So can you throw some light on this, please?
Yeah, the Jal Jeevan Mission is for the rural water areas, and it is targeted at a supply rate of 55 liters per capita.
So is it supposed to go up to 100 in the near future?
No. I'm just, I just said an example. I told you, we have successfully implemented 24/7 water supply in 400 villages. 400 villages, not one, 400 villages that ran into 24/7 water supply for 10 years. It was a KFW funded project. It had a very good community participation. Even before implementation of the project, these committees were formed. Villagers were, when we approached the villages and told them we are going to provide a 24/7 supply, they just made fun of it. कि साहब 4 दिन में ही पानी नहीं आता, आप एक रोज भी पानी देंगे बहुत है, 24 घंटे की कहाँ बात करते हैं. But slowly and gradually we convinced them. This was a good construction. Earlier we were using AC pressure pipes. When the German funding came, they said, no, we will not allow you AC pipes because AC fiber is dangerous and carcinogenic. So they said, you provide PVC pipe. So we used quality PVC pipes. There was very good quality control on the projects. There was NRW was below 10%. Even with long distances from one reservoir, cluster reservoir, at least 15-20 villages were being served. And they were, the reservoir was being filled from a distant pump house, and there was a float in the reservoir. When the reservoir used to get full, the pump would automatically tip, the pressure would rise. And the water supply was through the public stand post. So villagers were so involved in the management that not even a drop was wasted at the public stand post. The tap was kept as it is. And if you visit the village, you could see that it is dry and whether water is coming or not. There was a meter at the start of the village. That's called the village transfer chamber. The meter reading was done jointly by departmental engineer and the village committee people. And they were collecting the revenue from everybody. So they knew the value of water. Now what we have done, increasing the numbers, we have forgotten the community participation. It is there theoretically on the paper. There has to be a village contribution of 10% of the cost. but it's being subsidized. There are, I mean, no community actions per se, strong community actions. There are no involvement of the community in the management of the water supply system. And it is free. So it doesn't have value. And the distribution model would not work unless you have a demand control. You know, कहने को तो वो सब जगह connection हो गया, but in the fact the water is reaching in villages once in 3 or 4 days because they are making sub zones within village also. So every sub zone is getting water once in 2 or 3 or 4 days. मिल रहा है पानी ठीक है, but और village के लिए even 55 LPCD if they get at the consumer end, this would be good enough, I can tell you. Earlier even the towns had a norm of 70 liters per capita. अब इसको 135 कर दिया है. Thank you.
Thank you. Thank you, sir.
Thank you, sir. With that, I bring this session to an end. Let us give a big hand for the speakers, and I'll ask for the memento as a token of our love and appreciation.
Aro Swaroop. Dr. Ajit Salvi.